Mary and John are both saving money for a bike that costs $650. Mary has $225 and is saving $50 a week. John has $100 and is saving $75 a week. So I have a few questions here. When will Mary and John have the same amount of money? Who will get a bike first? Show your work graphically and algebraically. So first of all, when we start off, this problem is a lot like the phone plan problem. It's a lot like the amusement park problem. So we're going to look at week and how much Mary has and how much John has. So if they are saving, if we consider week 0 right now, Mary's starting with $225 and John is starting with $100. Then think, okay, a week from now, Mary is going to have saved $50 more. So she's going to have $225 plus 50, and John's going to have 100 plus 75. So he'll have 175, she'll have 275. In 2 weeks, she has her 225 plus 2 times 50. He's going to have 100 plus 2 times 75. So she'll have 325, he'll have 250. So you can kind of see how this is going and how it's similar to what we did before. So we can actually do this graphically. We can show our lines on the graph, and I'm going to jump to week 5, and so I can get a number a little farther out. So we would have 5 times 50. So we have 225 plus 250. So at this point, she would have 475, so still not enough to get the bike. John's going to have $100 plus, if we do 5 times 75, it's going to be 375. Oh, what do you know? I didn't mean for that to, I just found when they have the same amount of money. So if we look at a graph on this, so if we look at this graph, and we're going to put week on the x-axis, and we'll put the money that they have here. Then Mary, let's think how we're going to plot this. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. Probably big, long enough. And then for money, I think we need to get up to 650. So 100. Okay, so then 0 to 25. So that's 250. So here's 225. Then we have at week 1 she has 275. At week 5 she has 475. And I'm going to draw my line. Then for John, switch to red, 0, 100. Then at 1 week he had 175. And after 5 weeks he had 475. And I'll draw my line. So we get something that looks like this. So as far as who will get the bike first, when we want to know who's going to get to that $650 mark, it looks like John is the one that I have in red, so it looks like John is going to get there first, and he would get there, it looks like, well, I guess I didn't go far enough. But definitely he will be the one that gets there first, because at that point, at the 5-week mark, because John is saving more per week, his is a steeper line, and so he's going to get to that $650 first. Now, as far as how we would do this algebraically, so if we go ahead and we write our equation, for Mary, we would have, I'm going to use X and Y, so I'm going to use X for the week and Y for the amount of money. So for Mary, we would say Y equals, she's starting with $225 and saving $50 per week. And John is starting with $100 and saving $75 per week. We want to know when they're the same, so we're looking for the solution to the system of equations. Both of them are solved for Y, so we can actually set them equal to each other. And then solve for X. So I'm going to subtract 50X from both sides, and then subtract 100 from both sides. So I get 25X equals 125. So when you divide by 25, you get X equals 5. So in 5 weeks, they both have, and we already know it's 475, but if we didn't, we could take the 5 and plug it in and to either equation, and you would get 475. So we can do this algebraically, we could do it graphically. You should know how to do both. So this section, and we're spending a little bit of time on it, solving systems of equations, we've already talked about how to do graphing. We've already talked about how to do substitution, which is one of the ways to do it algebraically. We're going to learn a new way today. I'm going to skip over those, and actually I'm going to skip over these for now anyway. And I want to talk about the elimination method. And this first step to using the elimination method is you multiply one or both equations by a number to result in 2 equations that contain opposite terms. Then you're going to add the equations, eliminating one variable, which is where it gets its name, and then you solve the equation, and you will have to substitute to solve for the other variable. And you might not understand exactly what I meant by that, so let me show you an example. This actually, I love this method to do the substitution or the elimination method. So we want to solve this system of equations. Now what we would like to have to happen is we would like these to be opposites. So I'm going to leave my first equation alone. I'm not going to change that. But I'm going to multiply this bottom equation by a -1. So it's the same concept that I did with fraction busters, except there's no fractions, but I'm just wanting to make this be a -x instead. So I have to multiply everything by a -1. So I get -x minus y equals -6. Now what I'm going to do is add the 2 equations together. I'm going to add all the like parts. Well, what happens is these cancel out. And then I'm left with 2y minus y, which is y, and 10 minus 6, which is 4. Y is 4, and that is solved. So the nice thing about the elimination method is usually it's pretty simple to solve for the first one, but then you have to go back in and substitute into either equation. I'm going to choose the second equation, and I'm going to plug in a 4 where the y was, and I get x equals 2. So my solution is 2, 4. And remember what that means. If I graphed these 2 lines, they're going to intersect at the point 2, 4. So that's the elimination method. And the goal is you're trying to set them up as opposites. Now, I didn't have to do it that way. I could have multiplied the bottom equation by a -2 and made the y's drop out. So there's different ways you can do the elimination method. Okay, so here's like a practice. So you might want to pause this and practice this problem. So this one was pretty much set up the same way. So you would take either equation. I could do the top equation if I want to, but I'm leaving the first equation alone and multiplying the bottom equation by a -1. Remember, the -1 times -3 is +3. The x's cancel. I'm left with -2y equals 8, y equals -4. Remember, you're not done yet because you have to solve for x. So it doesn't matter which equation. I'm going to go into the top equation. So I get x plus 3 times -4 equals 5. So x equals 17. So my solution is the point 17, -4. Okay? Here's another system to solve. Now, notice on this one, the y's are opposite, but they're not the same number. So I can't turn the 3 into a 2 or the 2 into a 3, but what I can do is I can turn them both into 6's. So on this particular problem, I'm going to have to change both equations. So I'm going to multiply the top equation by a 2 and the bottom equation by a 3. And then watch what happens. When I multiply the top equation by 2, I get 4x plus 6y equals 24. And multiplying the bottom equation by 3 gives me 15x minus 6y equals 33. Now, the reason I picked the 2 and 3 is look what happened to the y's. I have a positive 6y and a negative 6y. So when I add these two equations together and I add all the like parts, the y's drop out and I get 19x equals 57. And if you divide by 19, we get x equals, these are nice numbers, 3. So remember, that's not done yet. You have to go back into either equation and solve for y. So I'm going to go to the first equation, no particular reason, plug in a 3 for the x, and solve for y. So I get 3y equals 6 and y equals 2. So the solution is 3, 2. So if I were to graph these two lines and looked for where they intersect, they will intersect at the point 3, 2. All right, this one solved the system of equations. So looking at this, what I usually try and do is it possible to just change one equation and not change both? I mean, I could change both. I could multiply the top equation by a 5 and the bottom equation by a -3 and turn it into a 15y and a -15y, but there's an easier way. I have an x here and a 2x here. So if I take the top equation and multiply by a -2, I can turn this into a -2x, and then I already have a +2x, so it's just less work. So when I do that, I get -2x minus 6y equals -14. The bottom equation doesn't change, 2x plus 5y equals 10. When I add all the like parts, the x's drop out. I get -y equals -4. Now that's like saying the opposite of y is -4, which means y is +4. You could think of it as multiplying both sides by a -1. So now I know y, but I have to figure out x. If I go back into the top equation, and I can go to the original part, so I have x plus 3, put a 4 in for the y. So we get x equals -5. So -5 comma 4 is my solution. So we have 3 different methods we've talked about. One of them is graphing, one of them is substitution, and one of them is elimination. So then the question is, how do you know which one to use? So I just wanted to kind of talk about that. As far as graphing, I would use graphing if I was allowed to use my calculator. So if using a graphing calculator, otherwise, graphing is probably not going to be, the way that I would want to just come up with my system of linear equations. I probably am not going to do graphing unless it was a problem like the bike problem or the phone plan problem where a visual is needed. And so that might be one. A visual is needed, like in a story problem. If it adds a little bit of context to the problem, then it's kind of nice to graph. When I would use substitution, if both equations are solved for y, either an x or a y, so both equations solved for a single variable. So for example, if they were both in slope-intercept form, so I'll say both in slope-intercept form, that would be an example of when I would do substitution. Or if one equation is solved for a single variable. Now, my method is different for both of these things. If they're both in slope-intercept form, I set them equal to each other. If one equation is solved for a single variable, then I put the one equation inside the other equation. When do I use elimination? When the equations are in, when equations are in standard form. And remember, a standard form looked like ax plus by equals c. Now, on some of your homework problems you do in the textbook, they say things like solve using the substitution method or solve using the elimination method. I don't really care. Like when I give you a test or a quiz, I'm not going to tell you which of those methods to use. You get to choose. So that's why, if you always want to solve for y and use substitution, you can, but it's not always the easiest way. So it's kind of a skill to be able to tell what's the best way, what's the easiest way, what method should I use, and that's where this little chart can help you. So hopefully that tells you what to do for your assignment, solving using the elimination method. And if you have any questions, you can let me know.